I chose to do my project on occupational therapy and the benefits it provides to patients that are suffering from post-stroke hemiplegia. I chose this because stroke patients are very often referred to occupational therapists for rehabilitation. 600,000 Americans will suffer from a stroke each year. This makes having a stroke the number one neurologic cause of disability in adults. What is an occupational therapist? An occupational therapist treats injured, ill, or disabled patients through the therapeutic use of everyday activities. They show patients new ways of thinking and how to still be able to do the things that they love in a different way. They also take into account all aspects of that person's life to provide a unique technique to each patient. And what is post-stroke hemiplegia? It's a weakness of one side of the body, and it makes it harder for a person to do daily things that were once not a problem for them. This is common to people that have had a stroke. So this research study consisted of 20 people total, and subjects would participate in a pre-evaluation, immediate post-training evaluation, and a 2-week cessation of training evaluation. The tests were a walking test that tested the ability to improve walking by training these individuals to step over obstacles, and the obstacles' height and length would each be different. The balance test would have subjects standing with their eyes closed, their left leg only, right leg only, and eyes open. The obstacle test, subjects were given 3 chances to clear a foam object. Length of that object was determined by length of the person's leg, and the 6-minute walk tested how far the subject was able to walk in only 6 minutes. Data was collected at every stage and analyzed at the end. And what is AR? AR stands for augmented reality, which is an indirect live view of a physical, real-world environment where elements are computer-generated perceptual information. It includes visual, auditory, somatosensory, and olfactory sensations. So the training consisted of 6 sessions for 1 hour over a 2-week period. The subjects were split into 2 groups of 10, and the actual reality group would wear a gait belt and step over foam objects walking down a hallway, and the augmented reality group would walk on a treadmill of their individually selected pace while an overhead harness held them into place. They wore a virtual research V6 head-mounted display to view the real-time image produced by a camera, and the obstacles were virtual. They would take vitals before and after each session just to monitor how they were doing, make sure that they stayed at safe levels and everything. Feedback from patients was overall positive. No dizziness, falling, or tripping was reported by any of them. And they really liked this way of training with the augmented reality. They stated that the lateral view that it gave of the legs provided a useful visual cue to step over the objects. It also allowed for them to be aware of the position of their feet and control stepping height and length. Immediate post-training evaluation had shown improvements in every outcome measured except the step length. The group receiving the AR training had significantly faster walking speeds and longer stride length. AR protocol results showed greater improvements when compared to real object protocol 7 out of 10 times, and the 2-week post-training and cessation of training had shown overall subjects had 95% retention in all of their key gait parameters. So these tests were able to really help the individuals with everyday life and independence, and overall the virtual object training had produced more significant walking speeds. So some of the major improvements were in the gait parameters, ability to clear an object, and walking endurance.